Alright, so here's the third video, and I would like to go through at least the first three questions here on the distance, speed, and acceleration questions, and to try to give you a sense of how to solve these kinds of word problems, what approach. I know I mentioned if you haven't watched the method for solving physics problems, you should watch that, or at least read through that on your previous. This is what it previously looks like here. The method here, I'm going to be using that method. I have it right in view, in my view, so I can reference it directly. And we're going to solve these questions. So the first question, it says, Dessa sleepwalks 105 meters in 14.3 seconds. On average, how fast does she sleepwalk? So the first step to do is to draw a diagram if needed to help clarify the situation. This question is extremely straightforward. Dessa is just sleepwalking, and we're given how far and how long it took her. Okay. It wouldn't help very much to draw a diagram of someone sleepwalking. You can pretend people sleepwalk like this. You could draw it something like that. Their eyes are closed. Could draw a stick figure like that and say that basically, well, that's basically the diagram. You could actually sketch it out, I guess. You can say this distance is 105 meters, and the time this was 14.3 seconds. You could do that, but I don't know that it's that helpful. So what I would do though is state the given variables. What is given? Well, 105 meters is given right here, so that is the distance. Now, what are we going to say? Is this the instantaneous distance? Is this the average distance? Is this the constant? Is this the constant, sorry, or is this the change in distance? And hopefully you can start to figure those kinds of things out. This here is the change in distance. Went from, if someone sleepwalks for 105 meters, they've gone from whatever distance to 105 meters away. So this is the change. So delta D is equal to 105 meters. And this is the time, and indeed it is delta T. And delta T is 14.3 seconds. Okay. Make sure you write down your value as well as the units. Okay, and this is S for seconds, M for meters. Then, on average, how fast does she sleepwalk? What are we asked to find? The average speed. So on average, how fast? So the average speed, that you need to know that symbol is V bar for average speed. Okay, you can refer to the previous sheet. We went through all that kind of in the notes and the table part. So the average speed is a thing that we're trying to figure out. So I'm going to say equals, and then I'll put a question mark to signify that we don't know what it is, but that's what we're looking for. So now from this information, and I don't think there's nothing else hidden here. I mean, I created the question, so I can tell you there's nothing else hidden. You know, we don't need to know the acceleration of gravity or anything like that. From these variables here, and knowing that we want to find V bar, which equation should we use from up here? Now I've also included them on the side here, in case my hand blocks it or anything, or in case after we do, not the first three won't affect it, but maybe we're in 4 and 5 and I kind of scroll the page up, then I'll have the formulas over here. So you'll notice that there's one that has V bar in it, and there's another one that has V bar, and this one says if the change in acceleration is equal to 0. Well, as she's sleepwalking, we're not sure if the change in acceleration is equal to 0. But that just means the acceleration is constant, and we don't know that. It could be this, but this actually is only useful if we knew the final and the initial speeds. and also if the acceleration was constant. And then this is just gravity is equal to 9.81 meters per second. So it has to be this one here. Okay, and the beauty of this one is that v bar is equal to delta d over delta t. The beauty is the delta v, or sorry, the v bar is already on the left hand side, and everything else that we know is on that side. So now we can just simply plug in the numbers, and I tend to just go put equals again, and then just like once I get to this stage, equals, and then delta d is equal to 105 meters, and I would encourage you to continue to put the units in every time and not just put numbers in, and then 14.3 seconds. And the reason why I put the units in there is because it's meters over seconds, which is speed, meters per second. So it's nice to see that in the equation. Now, what is 105 divided by 14? Now, what you can't see right now is I'm going onto my computer here, because I actually don't know the answer to that. If you have a calculator at home, you can definitely type in 105 divided by 14.3. I'm just going to go on the computer and then just put an equal sign, press enter. Alright, it's telling me that it's 7.342657342266, and it continues on forever. Now here's the thing. Oh, and this is meters per second. Here's the thing. You can't start just because it had a whole bunch of digits afterwards. You can't report that you have this significant of a result. In the question, meters and seconds, both of them have 3 significant digits each. And so when you do a division or multiplication, your answer can only have as many significant digits as the one with the smallest, the question, the value in the question that is the smallest. So in this case, they're both 3. This is 3 significant digits, and this is 3 significant digits. So they're both the same, so the smallest is 3. If it was 2 and 3, then the 2 would be the limiting factor. If it was 1 and 3, 1 would be, that kind of thing. So we're allowed to have 3. Now, we're allowed to have these 3, so you look at this, the number after the third significant digit, which is the 2, and that 2 either rounds the 4 up to 5, or it keeps it at 4. And the rule is 0 to 5, or 0 to 4, it stays the same, and 5 to 9, it rounds up. Okay, so this is just your rounding rules, and these are the most common rounding rules. There's actually other ones that we could use, but that's the one we're going to use for this class. So this becomes 7.34. 4 stays the same, meters per second. And that'd be your answer right there. Alright, let's look at the next one here. Ryan went to Mars to see if he could step off the roof of a house and not get hurt. If it took him 2.4 seconds to fall and he reached a final velocity of 8.91 meters per second, what is the acceleration he experienced due to Mars' gravity? So let's take a look. This one almost feels like it does deserve a diagram. We got a house on Mars, and Ryan jumps off to the ground. Okay, to see if he will not get hurt. We have the acceleration of gravity, so we could put that. The gravity is equal to, actually gravity in this case, because he's falling straight down, is going to equal the average acceleration. It's also the constant acceleration, and oh, that's what we're trying to find. So I'm going to put question. What is given? It took him change in time of 2.40 seconds, and he reached a final VF of 8.91 meters per second. Now there is something hidden in this question. So if this is VF here, just before he hits the ground, that's his final velocity, and his final velocity is 8.91 meters per second. What is his initial velocity? So if you're just stepping off the roof and falling, that's just like a dropping from stationary. You're not diving down, you're not jumping up and then down. So this actually you can say is 0 meters per second. And that you're going to find is actually quite useful information. So I'm going to put that here. VI is equal to 0 meters per second. Okay. What equation will I use? So I'm going to use something that says A bar is equal to something. And if I look through all these questions, I have one here. That's it. That's the only one with acceleration. This is not part of the equations. This is just a statement. If this condition is true, then use this equation. So this is an equation, this is an equation, and this is the only one with A bar. So I'm going to use that for sure. And it says delta V over delta T. I'm looking for A bar, so that's nice. The question is, do I know what delta V is and do I know what delta T is? Well, delta T is here, but delta V is not. So I need to almost find another equation that has delta V in it and use whatever value delta V is equal to and plug that into this equation here. And this is a substitution method that you'd learn in algebra, in math. So delta V, there's an equation here with delta V in, and there's an equation here with delta V. Now we can't use this equation again because we've already used it once here. So it would be no point in us saying, well, I can rearrange this equation and put it inside of itself. That you should not do. That's not a good technique. It will not get you to what you want, to your answer here. Instead, we're using a different equation that also has delta V in it, so both here, and we're going to substitute VF minus VI for delta V. If delta V equals VF minus VI, we can take that VF minus VI and put it into this equation. So I'm going to go A bar is equal to VF minus VI divided by delta T. And now you should see that why it was important for us to know VI. VI is 0, VF is this, delta T is that. We have all these variables, so we can simply put it in. If at this point you didn't have VI, you would probably be trying to figure out where to find it. It's not stated here clearly. So this is one of the things where you have to think a little bit outside the box to realize that it's implied that it would be 0. And if there's sometimes I design questions that are not very clear or could be interpreted different ways, and that's a problem with the question. Not the problem with the math, not the problem with the physics, but with the question itself. So again, I'm going to go over here. I have 8.91, and I'm just putting this in the computer, divided by 2.4, and that gives me an answer of 3.7125 meters per second squared. So it's meters per second divided by seconds, so that's meters per second squared. Now I'm not done yet, because even though I'm reporting 1, 2, 3, 4, 5 significant digits, if I look in the question, I have one here that is 3 significant digits, and I have one here that is 3 significant digits, and this one here, this is an absolute value. And so if we had more time to talk about significant digits and numbers, I would tell you about how absolute numbers, or like, for instance, if I said how many people are in the classroom and there's 3 people in the classroom, it's an exact number, 3. And so an exact number has an infinite amount of significant digits if needed. So it's the same with this one. It's exactly 0 meters per second. And so this one has no effect. So it's the 3. So we're allowed to have 3, 3.7. This 2 doesn't have any effect on the 1. It just stays the same. So it's 3.1 meters per second squared. Okay. We'll do one last question here. Yeah, one last question. Shannon was running laps in the gym. Lena decided to run beside her. At first, they both were running 11.0 kilometers per hour, but then Elena, which is really fast. Actually, it's not killer fast, but it's a jog. But then Elena went into beast mode and ran 25 kilometers per hour, which I'm actually wondering if that's like Usain Bolt levels, I think. Maybe, let me just find out how fast he ran, because I have a feeling that's a little bit, that's a little unrealistic. But I guess that explains the beast mode here. Okay, so it says 27.8 miles per hour was his top speed, which is great if we were in miles per hour. 27.8 miles per hour to kilometers per hour. Again, you can use a so it's 44.7 kilometers per hour. So I guess it's not too ridiculous, but that's fast. That's a fast pace. That's a sprint for sure. What was the change in speed in meters per second? Meters per second. So again, probably a diagram is needed. The two of them are running together, then Elena just runs faster. That's all. So what do we write down? At first they both were running this, and then she runs this. So we're going to call this first speed. We're going to call it the initial speed, kilometers per hour. And after they went to beast mode and ran at 25 kilometers per hour, so that's going to call the final, V subscript F, and that is 25.0 kilometers per hour. With this subscript, if I make it very large, it's V, and then the I would be down there, actually a little bit like below the line here, and the same with the VF. But when I actually write it smaller, often I write them fairly similar size, just because I don't want to go too small. So just know that that's what I'm doing there. And what was the change in speed? The change is delta V. The change in speed, what is it? So the question now I have is there an equation up here that has delta V? And indeed, there's delta V here and delta V here. So which equation do we use? Well, in this instance, it is actually the most obvious. In other questions, it won't be very obvious. And even in some questions, it won't matter which one. You'll have to eventually use both. But in this case, this one has VF and VI in it, and you know VF and VI. So there's only one equation to use here. Delta V is equal to the final minus initial. It's basically, by definition, the change in velocity or the change in speed is the final minus the initial speed. So we can just substitute in right now 25.0 kilometers per hour. And again, I'd encourage you to write out the units when you do this, even though it takes more work. 11.0 kilometers per hour, and that is 25 minus 11. So that better be 14. And there's significant digits here. It's going to end up being 14.0 kilometers per hour. For addition and subtraction, the rules for significant digits are different. And so for instance, if I have, well, maybe I'll do it over here, 25.0 and minus 11.0. If you remember how to add and subtract, you line up your decimal. You do the same thing here. And you do the subtraction, so that'd be 0, 5 minus 1 is 4, 2 minus 1 is 1, and then you put your decimal in the same spot. And for this one, for the how many significant digits you can have in your answer when you add or subtract, you have to look at the least precise value. And in this case, both of them are precise to the 10th position, and so you're allowed to go to the 10th. But for instance, if we had 25 minus 11.0, like this, okay, we would still have the same answer, 14.0, but this one here is only precise to the one's position, and so we'd have to say that it's actually 14, because this here would round up or stay the same, and the 0 makes the 4 stay the same. Okay, But that's not the case for this one. This one we have significant digits in the 10th place, so your answer is right here. The change in speed is 14.0 kilometers per hour. So what I'd like you to try is to complete all the questions here. Again, if you're able to print this out, I would encourage you to do that. You can print double-sided. I've just printed single-sided because when I go through it, I don't want the work from the previous page to be leaking through. But what I'd encourage you to do is to print double-sided and just go through it and see which questions you can answer. And I've included 4 pages, and you can see by the length of some of them that it'll take a lot more work. And so I tried to give you relatively easier questions to start off with for the first couple pages, and then it gets into more difficult ones. So do as many as you can, and sometime this week I'll post the answers and how to do them. Good luck.